In this example, we will use a traditional method to test the claim that the experimental nasal spray cuts the children's chances of getting the flu. Let's start with HO and H1. If the experimental nasal spray cuts the chances of children getting the flu, then the proportion of those that get the nasal spray and who get the flu should be less than the proportion from the other group. So there's our claim. The null hypothesis always has an equal sign, so P1 is equal to P2. We will need to find the test statistic, but first we will need to find P hat 1, Q hat 1, pooled P, and pooled Q. So P hat 1 is equal to, there were 14 children who got the flu out of 1,070. So working that out and rounding to 4 decimal places, you should have 0.0131. P hat 2. There was 95 children who got the flu out of 532. Working that out and rounding to 4 decimal places, you should end up with 0.1786. So pooled P is where we group the two samples together. So in the numerator we have the total of those who got the flu, 14 plus 95. In the denominator we have the total number of children, which would be 1,070 plus 532. So when we do the adding, that would give us 109 over 1,602. Divide that out, round pooled P to 3 significant digits, and you should get 0.0680. Just a reminder that that 0 right after the decimal place is not significant. We also need to find pooled Q. And that would be 1 minus that number that we just found. And that would be 0.932. Now we can find the test statistic. Z is equal to P hat 1, which is 0.0131, minus P hat 2, which is 0.1786, over square root of pooled P is 0.068 times pooled Q, which is 0.932, over the first sample size of 1,070, plus on the second fraction the numerator is the same, 0.068 times 0.932, but this time we need to divide by the second sample size, which is 532. Working that out, reminder you should round Z to 2 decimal places, so you should get negative 12.73. You can also use your calculator to find Z, and in this case you would get the same answer of negative 12.73. Watch the following viewlet to learn how to find Z on your calculator. Next, we need to find any critical values. Well, from the less than in H1, we know that we have a left-tailed test. Now, they did not give us a significance level, so whenever that happens, you should always use 0.05 for the significance level. So we have 0.95 to the right. Using table A2 or inverse norm on your calculator, you should find that the critical value is negative 1.645. The test statistic of negative 12.73 is to the left of negative 1.645. And since the test statistic is in the critical region, we need to reject HO. So the claim was with the alternative hypothesis and we're rejecting the null hypothesis. So that means there is sufficient evidence to support the claim that P1 is less than P2. One more question. Is there sufficient sample evidence to support the stated claim? Yes, there is.